at Adani GEMS Education and Research Institute, Mumbai. He is distinguished educational leader with over 3 decades of experience. Recipient of the President of India's National Teachers Award 2006, he is an expert in Six Sigma, NLP, TQM, SQAA, and 5S. Author of 200 plus books and creator of 150 plus educational apps. His innovations are recognized by Limca and India Book of Records. He is also mentor NCTE's National Mission for Mentoring. I request Dr. Dheeraj Malhotra for his introductory remarks.
Thank you. Well, dear esteemed scholars, academicians, students, and I won't say professionals, but IoT professionals. It is my profound pleasure to extend a warm and heartfelt welcome to all of you for today's insightful webinar on mining big data for IoT challenges, architecture, and applications. Well, this session brings together a vibrant community of learners, thinkers, and innovators who are united by their passion for technology and its transformative potential. I'm especially honored to welcome our distinguished speaker, Dr. Shriba PS, Associate Professor and Dean Academics and Research and Head of the Department of Computer Engineering at Lokmanya Tilak College of Engineering, Navi Mumbai. Dr. Shiba's extensive contributions to the fields of IoT, data analysis, and academic leadership have earned her deep respect across the academic and professional landscape. Her expertise, research, acumen, and of course, commitment to advancing knowledge promises to make today's session both enriching and intellectually stimulating. I also extend a warm welcome to all participants, the researchers, industry professionals, faculty members, and students who have joined us from various institutions and regions. Your enthusiasm and engagement amplify the purpose of this platform to foster learning and, of course, encourage dialogue and inspire innovation. As the IoT ecosystem expands and big data reshapes the digital world, discussions like today's are essential for building a strong understanding of emerging technologies and their real life applications. Friends, let us look forward to a highly interactive and thought provoking session. I encourage each of you to participate actively, ask questions, and take full advantage of this knowledge sharing opportunity. Together, let us explore new perspectives, strengthen our academic community, and contribute meaningfully to the evolving landscape of IoT and, of course, that of big data. Thank you and welcome once again. Over to you, Mr. Puri. Thank you.
Thank you, sir. Now I'll have the pleasure to introduce our speaker, Dr. Shiba. So Dr. Shiva is an associate professor serving as Dean Academics and Research and Head of Department of Computer Engineering at Lokmanya Tilak College of Engineering, Navi Mumbai. She has been associated with the institute for the last 15 years. She earned her bachelor's and master's degree in electrical and electronic seven. She has more than 18 years of experience across academia, research, and administration. Dr. Shiba has presented and published papers at IEEE International Conference and authored articles in international journals. She has also contributed to the book chapter and published a book titled Research and Publication Ethics. She has played a key role in upholding academic standards as a reviewer and editorial board member for international journals and conferences. She has successfully organized numerous workshops, webinars, and faculty development programs. She has held various leadership positions, including NAC coordinator since 2017 and internal quality assurance cell coordinator, where she contributed to the successful completion of NAC accreditation cycles 1 and 2. She also holds the position of National Board of Accreditation NBA coordinator at the institute, playing a key role and making notable contribution to the NBA accreditation process. Dr. Shiba held key roles at University of Mumbai, serving as the chairperson of the syllabus revision committee and a member of the result moderation committee. Currently, she is the chairperson of the Board of Studies in Computer Engineering at Lokmanya Tilak College of Engineering, Navi Mumbai. She also serves as the Vice President of Institution's Innovation Cell at the Institute. She is recognized as the Fellow of IETE and is also a life member of ISTE. So that was the introduction of Dr. Shiba. Now I would like to invite Dr. Shiba. We can start with the session.
Thank you, ma'am, for the kind introduction. Good afternoon to everyone. So I'll be sharing my screen. Are you able to see the screen?
Yeah, it's
In full
okay.
screen mode?
It's visible.
Yes.
Your
Okay.
screen is
Okay, thank you. So today's topic is mining big data for just a minute. Yeah, today's topic is mining big data for IoT challenges, architecture, and applications. So before we begin, let me give you a quick overview of the today's presentation. So here I'll be talking about brief introduction about IoT, then big data and the convergence of IoT and big data. Then I'll be giving a brief introduction about big data lifecycle, then big data architecture. Then I'll come on to the challenges, application, and then I'll end the session with conclusion. So before we start, as I know everyone is familiar with what is IoT, but still I'll just brief what is IoT. So IoT is the short form for Internet of Things that refers to a network of interconnected physical objects or things that are embedded with sensors, softwares, and other technologies to connect and exchange data with other devices and systems over the internet. You can see here in this diagram. So there are so many things connected. So the things are communicating to each other. That is why we call it as Internet of Things. What are the core components of an IoT system? So when we talk about IoT, the core components are sensors, then connectivity, data processing, user interface. What are the sensors? So sensors are nothing but those are devices that collect raw data from the physical environment. So what are the things when we talk Internet of Things? So things, what are the things? Things are nothing but those are the physical objects. For example, oh, I suppose somebody is annotating. Can you just disable the annotating because somebody has crashed over it, the screen? Somebody is using the annotating.
Puneet, can you check it?
Yes, sir. Yes, sir.
Hmm.
Okay, now it's done. Yeah. Yeah, things are physical objects. For example, it can be thermostats, car, or medical sensors, or industrial machines. So those are equipped with sensors and actuators. So the sensors I already said it collect data from the environment, that is temperature, pressure, location, vibration, etc. But what are the sensors in an IoT system? Actually, we can think of sensors as eyes and ears of the IoT ecosystem. Then along with that, we have actuators also. What does this actuators does? So actuators allow the device to take physical action. So physical action, what does mean by physical action? Means it can be opening a valve or maybe turning off a light, switching on and off. Those things can be controlled by the actuators. Then comes the connectivity. What is this connectivity? So in IoT, we can think of connectivity as the nervous system. So once the data is generated, as we know that this IoT devices, it will be generating the data. So once data is generated, it needs to be transmitted to the cloud or a processing node. So this layer, there's a connectivity. This is responsible for transporting the data collected by the devices to the processing system. So it can be, it includes networking protocols, maybe like Wi-Fi, Bluetooth, Zigbee, 5G, LoRaWAN, etc. So next comes the data processing. What is this data processing? So data processing is basically the brain we can consider as the IoT device. So once the data arrives at the cloud or the edge server, it is processed. So it can be, it can be some simple task like checking if a sensor reading is within an acceptable range, or a complex task like running machine learning algorithms for data mining, or it or transforming raw data into meaningful information. So basically, processing means transforming raw data into meaningful information. Then comes the user interface. So there the actions takes place. So this is the visible layer that allows user to monitor the system and interact with it. So it generally consists of dashboards or maybe mobile applications or alert systems. So actually there only we'll get the final output. For example, it can be an alert or it can be a recommendation. So to reach the user, or it may be triggering an automated system. So in automated response back to the device, that is the actuator. So that is all about IoT. So next comes what is big data. So big data refers to data sets that are so large, complex, and rapidly changing that traditional data processing application software inadequate to deal with. Here you can see this is big data. So where this data is getting, where all this data is getting generated from? You can see WhatsApp, Facebook, online shopping, smartphones, emails, YouTube. So many places you can see that these devices or the applications are generating enormous amount of data. So big data is nothing but it is a combination of unstructured or semi-structured or structured data. It is collected by the organization. So we have to mine this data to gain insights. So we can use machine learning projects or predictive modeling for this analytical applications. So this kind of big data, it is like for the conventional system, it is very difficult for the conventional system to handle this scale of data. So we need specialized tools for such kind of data. So we can use tools like Hadoop. You might have heard about Hadoop, Spark, and advanced data mining technologies for effective processing. So the value of big data, it doesn't lie in the data itself, but it is the analytical insights that can be derived from it. So we need to derive analytical insights from the big data. Otherwise, it is of no use. Let us come to the big data characteristics. When we talk about big data characteristics, I'll just explain the 6 V's of big data. The 6 V's, the first one is volume. So you can see volume, then velocity, then veracity, then variety, variability, and value. So we'll see what is this volume. So volume, as you know that every second data is being created everywhere. From where the data is getting created? Maybe from social media or online purchases or mobile apps or sensors in machines, even smart devices at home also generating data. So every second the data is being generated. So this leads to an enormous accumulation of information. So today's organizations are not just dealing with gigabytes. Previously, it was like only in gigabytes. Now it is in terabytes or petabytes. The organizations are managing the data. So volume tells us the scale of modern data is unlike what we handled in the traditional system. It's unlike the traditional system, the volume here, which is in terabyte, petabyte. So that is what is meant by volume. Next comes velocity. What is this velocity? Velocity means it refers to how fast the data move, how fast a data move. So data is no longer something that we store and examine later. So it has to be, instead what we have to do is, the data is getting streamed continuously. So maybe live financial updates, for example, stock market. So people are every moment they are checking how the changes. So live financial updates, real-time GPS tracking. For real-time GPS tracking, as you know that if you are using Google Maps, you can see, I mean, while you are traveling, it is continuously the real-time data it is being taking. So real-time GPS tracking, then health monitoring device. Health monitoring devices also, it tracks our health conditions. So, and industrial IoT sensors. So the data is being generated constantly. So many decisions now we need to make instantly. So this continuous flow of information demands systems that can capture and analyze the data the moment it arrives rather than saving it and examining later. So it has to be analyzed. So that is, how fast the data moves. Third characteristic is veracity. So veracity means, it is just about trust. As we can see that data is coming from so many sources. So not all of the sources are reliable. So some may be incomplete, some may be inconsistent, or it may be misleading. So if our data is not trustworthy, then the insights we extract won't be reliable. So veracity reminds that the quality also matters instead of along with quantity. So not only quality also matters. That is what this veracity says. Next comes the variety. What is this variety? So as we can see that in today's world, the data doesn't look just one way. It arrives as, data can be in any form. It can be text, it can be images, it can be videos, it can be audio, it can be log files, so or spreadsheets or web clicks and more. And so the data doesn't look in one way. So some of it might be neatly structured. So if you are talking about spreadsheet, so in that it is a structured one. But when you are talking about videos or audios, or it is a mixed kind of files, most of it are unstructured or it might be semi-structured. So this diversity makes data richer. But it also means we need different tools and techniques to manage and analyze each type. So it is like we are getting different variety of data and we need certain tools for analyzing each type of data. Next comes variability. What is this variability? So as you can see that the data when we are talking, it is rarely stable. So it meanings or the patterns may be changing continuously or depending on the situation or the time. So, for example, the sentiments on social media, it fluctuates rapidly. It is not constant. Or maybe you can say the sensor readings. The sensor readings shift with environmental conditions. So, user behavior on websites also varies from day to day. So, today, a user might be liking something on website, tomorrow, that may not be the case. So, the user behavior on websites also varies from day to day. So, variability tells us that data is dynamic and our model needs to adapt to these changes. So, that is what is meant by variability. And the last characteristics, that is the value. So that is one of the important characteristics. So at the end of the day, when we talk about data, so data is only useful if it leads to meaningful outcomes. Otherwise, it is of no use. So whether, when it is improving customer experiences or predicting failures or personalizing services, or maybe enabling some scientific breakthroughs. So value is what transforms raw data into actionable insights. So value is very much important. So it is the reason big data exists in first place. So we have seen the big data characteristics. So when we put all those characteristics together, that is volume, velocity, veracity, variety, variability, and value, we get a complete picture of what makes the big data so unique. So the 6 dimensions helps us to design systems, or it will be helping us to choose the technologies and extract insights in today's data-driven world. So next, one more term I need to make you understand, that is data mining. So now we have seen what is IoT, what is big data, now data mining. So data mining is nothing but it is the process of discovering patterns, trends, and useful insights from large set of data using statistical, mathematical, and machine learning techniques. So basically it turns raw data into meaningful knowledge. So we are collecting or storing the data, but if you're not analyzing the data, what is the purpose? We need to get information out of the data. Then only it becomes useful, right? So here in this case, you can see in this diagram. So the data, first it is like, the data is generated, then it is being, data cleaning is done, then it is transformed, then this part is the processing of data. This processing is done like, cleaning, transformation and all. Then data mining is done for getting the interpretation insights from the data. So that insights is turning into the knowledge. So there are various data mining techniques. This like classification. So classification, it arranges data into predefined groups. Another one is association rule mining. So it discovers a relationship between large data sets. In anomaly detection, if there is any unusual data points or deviate or outlier, then it can detect. Decision tree is one method wherein which it's a tree-like model for it will be classifying. Then ensemble methods, it can combine various models to improve accuracy. Then another method is clustering, wherein which it will be grouping similar points together automatically. Then regression analysis is basically used when we want to predict a continuous value as the output. Time series analysis is done for the data which is collected over time. And neural network, it is it models, it is basically this are all the models complex relationships using interconnected node. Now if you see this data mining techniques, all of this data mining techniques have been used in the machine learning algorithms. So this is all about data mining. Now we'll go on to popular data mining tools. So these are some of the popular data mining tools, namely Python, H2O, Spark, RapidMiner. So these are the tools. Okay, now we will see how it is related to IoT. How this is related to IoT. So IoT is primary engine fueling the creation of big data today. And I already said what is the data mining. So without effective data mining, the massive streams of big data generated by IoT devices remain untapped, making the connected devices dumb instead of smart. So what is this data mining does is it provides the crucial link to transform the 6 V's into actionable intelligence. So that is how it is related. And here you can see in this diagram, see Internet of Things, it generates big data, and this big data is being, employed to some AI ML tools, and it is creating some insights. Or here you can see digital twin is created, and then this process is going on. So what we are doing is here that there's a IoT is the primary engine fueling the creation of big data. Now coming on to the convergence. So what does mean by convergence? So IoT big data, it represents the intersection of two technologies. And it is not about connecting devices, but it is about extracting intelligence from the massive stream of information they generate. So what is this convergence? Convergence refers to a powerful and necessary union of three major elements. What are those elements? Those elements are, one is IoT, another one is big data and data mining. IoT acts as the body, means it senses the physical world and generates continuous streams of data. That is what this IoT does. What about big data? Big data, it will be acting as the fuel. So it provides large scale storage and processing needed to handle this massive volume of data. Next comes data mining. Data mining functions as the brain. So what does it do? So it analyzes the stored data and extracts meaningful patterns and insights. So when these three things comes together, the supply of real-time data meets the demand for intelligence. So enabling smarter systems and more informed, we can we can easily make decision making. So this convergence is essential. Why it is essential? Because neither technology can deliver full value without the other. So it is like, without IoT, what will happen to big data? Without IoT, there won't be any data generated for this big data. So big data lacks a massive source of physical data information. And without data mining, what is the purpose of IoT and big data? So without data mining, IoT and big data are just expensive storage and networking problems. So it is of no use. So the convergence is the point, is very necessary because it is a point where the supply of data meets the demand for intelligence. So let us see how this IoT data explosion, the new era of big data, how. So a study has been done. It has been given that IoT devices will be growing by 50 billion plus in 2027. And the big data market will be around $200 billion by the expansion of IoT expansion. Then what are the three critical dimensions which is there? That is volume, velocity, and variety. So as I already mentioned, the convergence of IoT and big data, it is actually creating a big technological revolution. So the devices which is ranging from smart thermostats or to the industry sensors, it continuously, stream terabytes to petabytes of data daily. So fundamentally challenging how we collect, process, and extract value from information. So that is a big task that ahead of us. So here in this diagram, you can see evolution of data in motion. So in past and emerging is given here. So in past, you can see as we think about maybe 10 years, 10 or 15 years before, the data, we were not using any smart devices or much of the things. So it is like, the data generated was also not very massive. So it was generally, the data was stored in an relational database management system where it was a structured one. And the normal, our extract, transform, loading process was taken and put it into the data warehouse. And then the data from data warehouse was taken for a business intelligence purpose. But in the emerging or the current scenario, you can see that data is getting generated from so many places. It is like logs, device, streams, apps, everywhere the data is getting generated. So this data, you can't simply store it in a structured way. So you can't use an RDBMS, normal database management system, won't work there. So what you have to do is you have to ingest this data. So that data we have to ingest and put it into some technology where we can store the data. So there are various storage methods by which we can store this big data. For example, Cassandra, Kafka, Elasticsearch and all. Then we will be using that data for analyzing. So then we can use AI ML tools or Agile BI for apps. And this is for the data customers. This is how, the evolution of data from past to now. So why big data for IoT? Why it is necessary? So when we talk about IoT, what immediately comes to our mind? That is, we imagine sensors and connected devices, right? But the real power of IoT comes only when big data analytics is applied to IoT. Is applied. So as you know that IoT generates vast amount of data. Okay, so it can be streams of temperature readings or motion signals. It can be health metrics, location logs, or machine parameters and more. So to extract value from this data, we rely on big data technologies. So what are these? So why big data for IoT? So it can be used for predictive analytics, automation, resource optimization, actionable intelligence. What is this predictive analytics? So predictive analytics means that we can forecast an equipment failure in industries, or we can predict traffic congestion in smart cities, or even we can predict health anomalies in wearables. So predictive analytics, we can predict all those things in advance. So second thing is automation. So what is this automation? So basically IoT system automatically behaves in real time, as we know, because switching off and on the devices or raising alerts, this all happens automatically. So how it is happening? It is by adjusting or based on, we are actually giving some rules. This actions are happening based on data driven rules, which we have already set. So based on that, it is the automation is done. So next one is resource optimization. So big data helps us to optimize the resources. Maybe it can be energy in smart grids, or maybe water distribution, or fleet management, or industrial throughput. What is industrial throughput? That is machine operation output. So we can reduce downtime. Reduce the downtime in the sense, for example, if the machine is in an industry, for a production factory, for example, if the machine is shut down, then what will happen? The production immediately stops, right? So if we can do this, if the machine failure happens, if we can predict it before, then we can take action maintenance before. So that is what we can reduce the downtime. Is the reduce the downtime means the failure time can be reduced. And this ensures also efficiency also we can maximize. So that is there. And another one, the big data is actually, it gives actionable intelligence. So what it does is, as I already said, the raw data is generated by this devices, raw data is generated. So this raw sensor data is turned into insights and through dashboards and then reliable discussions. So that is what, so IoT is just, it is not just connectivity. So IoT plus big data is what makes system, truly intelligent and predictive and efficient. So the combination is necessary. Now I'll go on to the big data life cycle. So here you can see that data discovery is done then data acquisition is done, then data extraction, then data preparation, then it is model planning, and then it is results and communication. So it can be, divided into several phases. I will go on to the next slide for explanation. So big data life cycle. So first is data generation. Second one is data collection. We call it as ingestion, then data storage, then data processing, then fifth is data analysis, and sixth is visualization and insights. So data generation, that is where everything starts. So as you know that millions of IoT devices are there. So that will be, with the sensors, RFID tags, it will be with cameras, machines. So this IoT devices will be generating huge amount of raw data. It is generating continuously. As you know that it is generating continuously. Here you can see that examples, temperature, GPS, video, wearables, all those things are there. So second thing is data collection. So IoT devices, when that will be sending data through lightweight protocols like MQTT, COAP, HTTP. And what does this gateways do? Gateways aggregate data from local sensors. It will be aggregating all the data from local sensors. And in large systems, we can make use of tools like Kafka, and that will be collecting real-time streams. So this things, the data collection step, this ensures that the data reaches servers reliably and quickly. So once the data is generated, next is the data collection. So that is, we call it as ingestion. Third one is data storage. So as we know, IoT generates massive data. So as I already mentioned, so if it is a massive data, then the traditional databases are not sufficient to store. So here we have to store in a distributed manner. So data is stored in distributed storage like Hadoop distributed file system. In short, we call it as HDFS. That is Hadoop distributed file system, or cloud platforms we can store the data. Or we can make use of NoSQL like MongoDB or Cassandra. So this storage handles dynamic unstructured data. So also, as you know that, the data is growing. So this storage also must scale automatically as the data grows. So that also to be taken care of. So next is data processing. So in data processing, what is happening? As I said, raw data will be generated by the IoT devices. So this data should be cleaned before use. Okay, so we have to do pre-processing. So pre-processing means noise removal, filtering, normalization, aggregation. So sometimes what is noise removal, filtering and all? Maybe sometimes, some repetitive data or some unknown, some missing values or such kind of data. Then normalization, aggregation is you can combine the data together. Maybe you can take the average or sum, all those things. That is meant by aggregation. So this has been done in pre-processing. So then we'll be using these tools like batch tools are work on historical data. So examples for this batch tools are Hadoop, Spark and all. So another one is stream. For stream processing, we'll be using streaming tools like Spark, Flink, Storm, etc. This all work on real-time data, this streaming tools. So this all help convert raw data into usable structured information. So from raw data, it is converting to structured information. Next comes data analysis. So in data analysis only, all the insights are generated. So insights are, and how the insights are extracted, it is being extracted by means of some machine learning models or statistical analysis or any AI techniques we can make use of. So the insights means, I can say example, predicting machine failure, or maybe detecting abnormal behavior, or forecasting energy usage. This all can be, examples of this insights. So this analysis helps decision making and optimization. Next comes visualization and insights. That is the last step, that one. So this insights, what is generated, that is being visualized by means of dashboards or reports. So or it can be, the users may get some real time alerts. uh, Users will be getting the alerts for any issues generated, or even insights. No, it can also trigger some automated action also. For example, this insights may trigger actions like switching off a device, or maybe changing the traffic signals, or adjusting the temperature. So this all things, based on the insight, the data is generated, is processed, and insights are taken, and based on this insights, actions are taken. Okay, so that is what is the big about big data life cycle. So basically it is generate, then collect, then store, process, analyze, visualize, or act. Now coming on to this ingestion technologies. So what is meant by data ingestion? So that is nothing but it is the process of collecting and moving data from various sources into big data systems such as Hadoop, Spark, data lakes, or cloud storage. So it is basically the process of collecting and moving data from various sources. As you know that it can be such as databases, applications, devices, or logs, or cloud platforms into big data systems. So here you can see that in this one, see the data is generated from various sources, and this data is being collected by means of data ingestion, and then it is being given for storage. So this ingestion is just collecting the data from various sources into big data system. So it can be done in three steps. So maybe it is like batch ingestion, then real-time ingestion, then hybrid ingestion. So in batch ingestion, what happens is the data is loaded periodically in bulk. So it is in kind of batches it will be. So common for daily or hourly updates. So if you want to, hourly update, you can keep it in a batch and then send, then collect it. Or hourly means in 1 hour, maybe you are collecting the data, and in a batch you are taking. So next one is real-time ingestion. In real-time ingestion, actually that is, the streaming data is captured instantly. We can't wait or store it. So the data is captured instantly as events occur. So when when the data is generated, immediately it is collected. That is real-time ingestion. And in hybrid ingestion, it is a combination of both. That is batch ingestion and real-time ingestion. So here this combines. So hybrid maybe sometimes, some business needs may require that one, batch and real-time together. So that is for that purpose we'll use hybrid ingestion also. So this big data ingestion technologies, basically it helped to automate and manage this flow effectively. So ensuring that the data, it also ensures that the data reaches the right system efficiently and reliably. So that is about the ingestion. Now, what are the tools? We'll see ingestion technologies overview. So here you can see there are various technologies we can use for ingestion. So one of them is Apache Kafka. So this is one of the most widely used real-time ingestion platform. So it is ideal for streaming and even processing pipelines. Apache Flowme is another one which is used for batch and streaming models, and it is commonly used for log ingestion into Hadoop. Then another one is Apache NiFi. So that is a flexible tool that handles that can handle both batch and real-time flows, and is popular for enterprise data ingestions. Then Apache Scoop is generally it is used for batch transfers between relational database and Hadoop ecosystems. Then cloud native systems like AWS Kinesis, then Google Pub Sub, Azure even Hub, all can handle high throughput real-time ingestion for cloud and IoT environments. And we have Logstat also, which is mainly used for log processing and feeding search engines like Elasticsearch. So here you can see this one on right hand side. You can see this data is being generated. Data is being generated and it is being ingested by means of these tools, Kafka, Flink, Kinesis, etc. And then it is being given for the storage processing. So next one is big storage technology. So here, first then data is generated, then it is ingested, then it is given for the storage. You can see here storage, then it is being processed. So the storage technologies are, HDFS, HBase, all those things. So HDFS, you might be very familiar with, that is Hadoop distributed file system. So this is actually designed for storing very large data sets and supporting batch processing. For real-time heavy workloads and time series data, we use HBase. And we can use this MongoDB and Cassandra for NoSQL databases. And it is ideal for dynamic and maybe scalable applications where flexible schemas are needed. Then for cloud object storage, we can use AWS, S3, Azure Blob, then Google Cloud Storage. So it is widely used for data lakes, long-term backups, and low-cost archivals. And we have this Apache Hive, actually, that can act as an SQL warehouse also. So allowing users can query using SQL syntax. Then we have Apache Kudu, that provides fast storage and supports quick updates and all. Then we have Redis and Memcached. So that serve as in-memory caches for high-speed, latency-sensitive workloads. That for that purpose we can use this. So here we can see that a real-time data stream from here, it is directly going to this. This is that ingestion is taking place, and then it is going to the storage, Cassandra, HDFS, and all you can see here. So after the storage, then the data has to be processed. So here, how can we process this one? So the big data processing engines, we have various methods. That is MapReduce is there, Spark is there. MapReduce actually the original Hadoop processing engine. So it works in a batch mode and it is best suited for heavy ETL workloads. Then Apache Spark we can use. It supports both batch and stream workload. So basically it is the Spark is used for machine learning, fast analytics, and iterative processing because it keeps data in memory and making it much faster than MapReduce. So since it is kept in memory, so that it will be more faster. Then Apache Flink is there. So it is for true real-time stream processing with low latency. Then it supports batch processing also. So another one is Apache Storm. That is another real-time engine. It is used for instant event processing. So commonly this Storm is used for monitoring and alerting systems. Then we have Presto or Trino. So this can be, fast SQL querying can be done using this one. So even users can run complex queries also with the low wait times using this method. Then we have Hive also. That also provides batch SQL query on Hadoop. So basically Hive is used for data warehousing, reporting, and transforming large data sets. So here you can see the diagram, the complete. So from the data sources, data is generated. Then the data is ingested. So ingested, then processing is done using the techniques which I said. It can be data process. Okay, so sometimes for big data, what is that is we do processing and then we store the data. But sometimes we have to store data for historical purpose. So for that we can store the raw data also. But this raw data Why we are processing before storing? Because it is a huge amount of data is there. So storing takes enormous amount of time. So that we'll be first process and then store it and then analyze it. So here, this one raw data storage is also we can do it parallelly before processing, so that the actual data we will get, that is without any filtering. And then the process data storage, and then we can visualize it. We can use graph and all for visualization purpose. So here it is the storage. You can see for storage we can use Hadoop, MongoDB, Cassandra, and all. For mining we can use Presto, RapidMiner, Elasticsearch. For analytics we can use Spark, Kafka, Name, Blockchain. Then for visualization we can either make use of Tableau or Plotly. Okay, now comes on to the IoT big data architecture. So this is the architecture you can see on the left hand side. So the bottom most you can see that is starting with IoT devices. This is the lowest level, IoT devices and sensors. So this includes embedded devices like actuators, wearables, industrial sensors. So what does this do? It, as I already mentioned, it continuously sense physical conditions like temperature, motion, vibration, location, and all those things will be dictated by this one, the lowest level. Then these devices connect to the network through the connectivity layer. So this connectivity layer, it includes technologies such as Wi-Fi, 4G, 5G, Zigbee, LoRaWAN, etc. So what is it? This layer, the connectivity layer ensures that the sensor data can be transmitted reliably over short or long distances. So this ensures that the data is being transmitted over short or long distances. Then before the data is reaching to the cloud, we often perform edge processing. So edge processing, in that it can be filtering aggression and some of the analytics directly we'll do on edge devices or gateway. So when we are processing it at the edge, what happens is like it can reduce the bandwidth usage. Only the required data will be going. So the reduces the bandwidth usage and allows faster responses for time critical applications. Then comes the ingestion layer. So in this ingestion layer, we will be using tools like Kafka, NiFi, Flume, or MQTT. So what does it? It collect and route high velocity data streams into big data ecosystem. So ingestion layer, it collect and route the data to the big data ecosystem. So this layer ensures that the data flows smoothly from devices to the storage and processing system. So here this layer is essential because the data from it ensures that data flows smoothly from devices and into the storage and then for the processing. So then the ingested data, as you know, that this is the collected data. Then that collected data we have to store it. So we are storing it. The ingested data is stored in the storage layer. So this can be HDFS, NoSQL, or databases. So cloud storage or data lake. So we can, this layer basically provides tolerant storage for real-time and historical data. So real-time and historical data, it will be done here. Then above storage is the processing layer. So where engines such as Spark, Flink, Batch processing frameworks all will be done here. So what does it do is it will be transforming raw data into meaningful information. So this is where analytics, machine learning, and even processing takes place. So finally, at the top we have analytics and application. So here we will be having our dashboards, then reporting tools, or any ML models which use process data to generate insights. So insights like automate decisions or support business operations, all those things. And so together, all these layers form the complete IoT big data architecture. So devices collect data, network transmits it, edge nodes refine it, ingestion, brings it into the system, then storage retains it, then processing, it extracts intelligence, and applications deliver value. So here you can see here the IoT devices, then this is the connectivity layer, then you can see the storage and then the analytics. Here you can see the dashboard and all those things. Now let us see the major challenges in IoT big data mining. So the major challenge is security and privacy concerns. So here, as you know that IoT devices often, it operate in open environments, and it will be collecting sensitive informations. So a weak security makes them vulnerable to attacks and data breaches. So security and privacy concern, it is a major challenge. So another one is interoperability issues. So these things arise because, as you know that this IoT devices comes from different vendors. Okay, so maybe it will be using different protocols, and maybe it will generate data in different formats. So it is difficult to integrate all those things. So that is a major challenge. That is interoperability issues. Another one is data quality and noise problems. So uh, sensor data sometimes because of the noise and all, the data can be inaccurate, or sometimes it will be incomplete data, or maybe it might have been influenced by environmental changes, so which actually affects the reliability of the analytics. So that is another concern. So another concern is high infrastructure and processing cost. So for handling massive continuous data streams, as we know that enormous amount of data is being generated, and for handling this massive and continuous data streams, it requires powerful storage, then networking also, and computation resources also. That is also a major challenge, the infrastructure. Then thinking about the sheer volume, velocity, and variety. So that adds more complexity to the IoT system. So systems must handle, actually it should be able to handle huge amounts of fast moving, diverse type data simultaneously. So that is a challenge because it has to be taken simultaneously. Also, IoT devices, it suffers from limited energy and bandwidth because because of this limited energy and bandwidth, it restricts how much data can be transmitted and processed in real time. So that is one concern. Another one is lack of standardization. So when we talk about the standardization, because it is resulting in compatibility issues, then inconsistent data formats across devices and platforms. There is no uniform format. So it is like, it will be creating complexity. Then another one is real-time analytics complexity. So that is a challenge because, many of the IoT applications, as we know, require instant decision making. So real-time analytics, which demands low latency processing. Low latency processing means less time in processing. Low latency processing and advanced stream analytics tools. So that is a challenge. It is because instant decision making is very difficult. So these challenges are not limited. So I have mentioned the major challenges, but lot of other challenges are there. So I have mentioned few of them. So together, these challenges make, IoT big data mining a demanding but crucial area of research and innovation. So maybe people have to do research on how we can overcome these challenges. Next is coming on to the IoT applications. So we have several applications. I have mentioned few of the applications here. So we will see one by one. First, coming on to the smart homes. So as we know that IoT enables home automation. How it is enabling home automation is through connected devices, maybe such as maybe limit lights, smart lights. Nowadays, I think almost most of the people are now using smart lights to save energy. So smart lights or smart locks, thermostats, and voice assistants. So this system improve convenience. That is the convenience for the people. Then enhance energy efficiency also. Then it can strengthen home security with real-time monitoring. So this all things can be done by means of the smart IoT in smart homes. So another application is in healthcare. So wearables remote monitoring. Nowadays, we can see that 90% or 80 to 90% of the people are using smart watches or maybe the fitness bands and all. So wearable devices like this smart watches and fitness bands. Actually, it continuously tracks our heart rate, then oxygen levels, then sleep patterns, and physical activity. So even remote patient monitoring also can be made. It will be, allowing doctors to check a patient's condition from anywhere. So which is especially helpful when for chronic illness management. So if the patient is unable to travel, or it may be for rural areas if the doctor is not available. So such kind of things can be done. So now coming on to the industrial IoT, that is for predictive maintenance. I already mentioned about it. So as we know that factories generally use IoT sensors. Why they use it? They use it to monitor machines and predict failures and before they occur. Okay, so see, the purpose is you need to predict the failure before it occurs. So this is called predictive maintenance, and this predictive maintenance helps in reducing the downtime. Also it increases the productivity and also lower the operational cost. So that is a good thing. If you are using industrial IoT predictive maintenance, it saves lot of money for the business. Another one is smart cities. IoT can be used to help traffic flow, or maybe it can be used to reduce congestion, monitor air quality, or it can be used for optimize street lighting, and waste management also can be done. Improve waste management. So all this contribute for a better urban living and sustainability. So that is very good application. So another very good application is in agricultural field for smart farming and sensors. So IoT, it supports smart farming through soil sensors. Maybe the sensors will be detecting the moisture content in the soil, or it will be giving indications or alerts to the farmers when to water the plants, like that. It can be detect low inventory. Soil sensors, it is smart farming through soil sensors, then automated irrigation, then crop health monitoring also can be done. So farmers can make better decisions using real-time data. So this will result in higher yields and efficient use of resources. So this is very helpful for farmers. Another application is in retail. So retail, that is smart shelves inventory tracking. So IoT enables smart shelves that automatically detect low inventory. That is in particular store, when a particular item is, the amount of item is less, so we have to restock. So that restocking thing, it will be alerted before, so that they can restock the item. So here enable chefs that automatically detect low inventory, then RFID-based tracking also can be done. Then personalized offers can be done in smart retail. Then even the people who are going for shopping, then smart checkouts can be done experience. So this all, are improving the customer experience or the customer satisfaction, and reduces the operational effort. Actually, it is reducing the operational effort in this retail industry. Another one is for the transportation, that is for fleet management or telematics. So IoT is actually a lot of benefits are there. So GPS tracking can be given, telematics sensors, and vehicle diagnostics. It can be used to help optimize the routes, or so that reducing the fuel consumption, and also, and even the safety also can be enhanced by means of this one. So that is about the transportation. So overall, IoT applications are, as you know, that transforming almost every sector by providing real-time insights, then improving efficiency, and enabling smarter decision making. So that is all about. I'll just show you a case study for this IoT application. So here there is a metropolitan city. It is facing increasing traffic congestion during peak hours. This is the case. Okay. So traditional traffic lights, it operates on fixed timings. So it will be leading to long queues, delays, and fuel wastage. So what the city authorities did is they deployed an IoT-enabled traffic management system to optimize vehicle movement using real-time data. So here we can see that this is they have kept sensors everywhere. So here the smart sensors here, it is giving, the data is stored onto the cloud platform, then data analysis is done, then using machine learning algorithm, the analysis is being done, and then this is passed on to the intelligent traffic management system. And then we are getting the output. So here, IoT data sources, this system basically integrates different types of IoT devices, that is heterogeneous IoT devices. So inductive loop sensors used to measure vehicle count and speed. Then CCTV cameras can be used for edge analytics for vehicle detection and classification. And GPS data, it can be data from public transport and taxis can be taken. Then environmental sensors, which measures the air quality, noise levels, and all those things. So then connected traffic lights with remote controllability. So the daily data volume, the data generated daily is exceeding 2 terabytes. So it is actually demonstrating true big data characteristics, that is volume, velocity, variety. So as we can see that, the system is integrating heterogeneous IoT devices. Now, here for this one, this is the device layer, sensors and controllers. Then we have the edge layer, wherein which the local network data processing, then cache, buffering, control, virtualization, everything happens here. Then the cloud layer, where big data processing and data warehousing happens. So what is the outcome for this one? So this big data architecture, data acquisition. So in edge layer, so here IoT devices, you can see here the data is generated. So in edge layer processing at roadside unit. Roadside unit is a device used along the road for finding. It is a device, roadside unit, reduces latency by it can, filtering noisy data, then detecting incident, that is accident, abnormal slowdown, then compressing video frames, and all those things are done. These are all processing. So processing is done at edge layer. Then ingestion layer. So in ingestion layer, real-time streaming tools are used like Kafka, MQTT channels to push data to the cloud. So in storage layer, we can use Hadoop, HDFS or S3 for large-scale historical data, NoSQL databases for, that is Cassandra and MongoDB for high-speed retrieval, and time series databases for sensor logs. Then we have a processing layer. So real-time analytics using this Spark and Flink. Then batch analytics using Hadoop, Spark, machine learning models, conjunction prediction, anomaly detection. All this has been done in a processing layer. Then we have the application layer, wherein which the dashboard for traffic authorities will be. So for the traffic authorities can see the dashboard, wherein which they can observe live congestion levels, then dynamic signal timing recommendations, then emergency vehicle routing. So this all can be controlled by the traffic authorities. So analytical insights generated using a big data model, that is one is adaptive signal control. So that reduces average waiting time by 25 to 30%. Then congestion prediction also, that is up to 15 minutes in advance they could predict. And incident detection, that is accidents or stalled vehicles within 20 to 40 seconds it was detected. Then pollution mapping, that is correlated with traffic hotspots, means the traffic hotspots it is related. Then machine learning techniques used, we have time series forecasting. For that, ARIMA and LSTM models were used. And computer vision for vehicle classification. Then clustering for identifying congestion patterns. So the outcomes, we can see the impact is 22% reduction in travel time. Then 18% decrease in fuel consumption. 40% faster emergency routing. 15% improvement in bus punctuality. Then data-driven infrastructure planning. So this were the impact, as you can see. So this is how this case study actually demonstrate how leveraging IoT and big data together creates intelligent, responsive, and sustainable traffic ecosystems. So I'll come to the conclusion. So to conclude, as you can see, IoT generates massive real-time data, and big data technologies are essential to make this information meaningful. A layered architecture helps us manage ingestion, storage, and analytics efficiently while addressing challenges like security, interoperability, and cost. So together, IoT and big data unlock powerful applications that continue to transform industries. Thank you all for joining today's session. I hope this webinar helped you understand how IoT and big data come together, the challenges involved, and the powerful applications they enable. If you have any questions, I'd be happy to take that. Thank you.
Thank you, Dr. Shiba, for such an informative session. Now we are open for question and answer. You can unmute yourself and ask the questions.
Yeah, I'm Apoor Vaga. Can I ask a question, please?
Yes, sir. Yes.
Sir. So, ma'am, congratulations. It was a meticulously planned presentation.
Thank you, sir.
One of the best that we have seen in our IoT Society presentations. Just one small question. Do we also have applications in space of IoT devices?
Sir, obviously it will be there, but the thing is we have to explore it more. So research has to be done.
Not yet started.
Not yet started.
Okay, thank you.
Because space, the communication here, it is, space internet of things, it is there, but I don't know how far it has reached. There is something called a space internet of things. So that is a different field wherein which, I think in the space itself, maybe some IoT devices they will integrate and then they can communicate at there. So that is called a space IoT. So I don't know how far the research has gone. Yeah.
Thanks.
Yeah.
Do we have any other question?
Yes,
Dr. Shiba?
please.
Yeah, sure.
Yeah. Myself, Dr. M.K. Misra from IIIT Prayagraj. What kind of security or privacy concerns are there related to IoT and big data analytics?
Sir, security and privacy concerns, I already told you. So that is, the data. So it is open, right? The most of this IoT devices, we don't know how it has been, where it has been kept. So it is open to everyone. So we need to have a proper, security constraints wherein which, the weak processing power. So default passwords. So we have to sometimes know insecure firmware. Then
Ma'am,
sometimes we may not be having the updates also done properly. So this all, maybe creating the security. Not only that, no, it can be attacked also. So
no,
maybe
ma'am.
sometimes no hijacking can happen for the device if
No,
somebody hijacks or
actually, big data or IoT is in public domain itself. So
yes,
we
sir.
are dealing with the public data or data that is available in the public domain. So if
Sir,
it is
actually,
already there in the public domain, what kind of privacy issues are there?
Sir, that is what, sir, privacy issues. That is what I am saying. The people can, anybody can take out the data, no? So proper encryption should be done. So we need to, authorize who can access that particular data. So see, the data which is public, it will be open, but for certain sensitive data, it should be properly encrypted and, properly authorized. Who can view that data like that? So authentication is most important.
Okay, thank you.
Yes, sir.
One student has placed a question in the chat. Yash Tiwari from BVS College, Prayagraj. Whether he is there or not.
Yes, Yash, you can ask your question. Okay, I'll read out his question. His question was, why do IoT devices generate big data at a higher rate compared to traditional systems?
Yes, ma'am.
So you mean to why? Okay, IoT generated big data at a higher rate compared to, okay. So basically what is happening is this IoT devices, it is continuously, sensing high frequency data. Okay. So real time communication. So the data, the speed at which this data is being sensed. So it is generating high velocity data. So as I already said, what is this big data? So big data, the characteristics also I said, well, one of the characteristics is the velocity. So that is what? So that is one of the things, the sensors. So many IoT sensors, every second or millisecond or microsecond, it is, capturing the data. That is why it is generating the big data at a higher rate compared to the traditional systems.
Do we have any other questions? Okay, so I close the question answer session for now. I now request Ms. Pankti.
Before going, I want to thank, or
Yes.
I'll thank later.
No, you can proceed.
Yeah, because I just want to say a few words. Um, I would like to express my sincere thanks to the IoT Society of India for giving me this opportunity, and my heartfelt gratitude to Sri Rakesh Puri sir, for Honorable Secretary, IoT Society of India, for inviting me to serve as a speaker for this webinar. I truly appreciate the honor and the confidence placed in me. Thank you once again to the organizers and to all the participants for your time and engagement. Thank you. Yeah.
Thank you, Dr. Shiva.
Hello, Dr. Shiva.
Rakesh, mute. If you're saying something, you are on mute.
Hello, Dr. Shiva. I'm sorry if you excuse me. I want to say something.
Okay, yeah.
Thank you. I'm Dr. John Kani from Ghana, Africa. I thank you for your submissions. I think it is very insightful. I wish I could get your slides so that later on I can reflect more on it and even share with other colleagues. So if you can provide the slides, I'll be very happy. Thank you.
Yeah. I'll share.
That was my question, Dr. Shiva. If we get the PPT, I will send it to all the registered members.
Yes, sir. I will share
the
it.
site.
I will mail it to you so that you can share it with the participants.
Thank you. Thank you. Yes, Shivanji, proceed.
Okay, so I'll invite Ms. Pankti Dalal from IETE Vadodara, Gujarat to deliver the vote of thanks.
Good evening, everyone. My first and foremost thanks to Mr. Rakesh Puri sir for giving me this opportunity to speak in this big webinar event. And to our respected speaker, Dr. Shiba PS, esteemed seniors, fellow members of IoT Society of India, industry professionals, participants, and my dear friends. As we conclude this insightful session, it is both an honor and pleasure to express our gratitude on behalf of IoT Society of India. Today's discussion on data mining has been enriching, forward-looking, and highly relevant in today's data-driven era. Dr. Shiba, thank you for bringing your expertise, clarity, and depth of understanding to today's session. Your ability to simplify intricate concepts ranging from pattern extraction and clustering to predictive modeling and real-world applications made the topic accessible and engaging for everyone present. Your session did not merely inform us, it expanded our perspective on how data mining shapes intelligent decision-making and fuel innovation across industries. I would also like to extend our sincere appreciation to the organizing team, technical support staff, and every member working behind the scenes who ensure a smooth and seamless webinar experience. Your coordination, efforts, and commitment are truly commendable. A special acknowledgement to Shri Puneet Pandey, Secretary IoT of India, Lucknow Chapter, for providing continuous guidance and technical support in organizing this event. Your encouragement and contribution plays a significant role in making knowledge sharing platform like this possible. To all the participants who join us with this enthusiasm and curiosity, thank you for your active engagement. Your question, reflections, and involvement added a meaningful value to today's session. It is through collective learning like this that we move towards a safer, smarter, and more connected digital environment. Today, we have taken a thoughtful step towards understanding how data mining can elevate the way interconnected devices and operate, how analytics can shape the future of IoT and behind. Let us continue to explore these insights, exchange ideas, and support one another in driving innovative solutions for our field. On that note, I wish everyone continued success and look forward to meeting again for future sessions filled with knowledge, collaboration, and growth. Thank you all for your time and participation. Have a wonderful day ahead.
Dr. Shiba, one thing I want to put on records, as Mr. Purvaga has told, that this is one of the best prepared and very informative session of IoT Society of India.
Thank you so
Very
much,
nice
sir,
lecture.
for your kind words. Thank you so much, sir.
Shivanshi, you can proceed. You can close the session.
Okay, so thank you all, and especially Dr. Shiba for her valuable time. With the permission of the members and the president, close the session now. Thank you.
Thank you very much. Thank you
Thank
all.
you.